Alright, hey everybody, this is Mr. Klein. I'm going to give you your demo video for the Unit 4 assessment. Oh, sorry, I'm supposed to hold the camera up like this. It's supposed to make me look better. So I'm going to be giving you guys the demo video for assessment 4. I'm going to show you the video, I'm going to show you all the materials, and then my son's going to record this. So I don't know if I can flip it around now. Well, that makes things tricky. How do you flip that around? Can you flip it around now?
You have to end it.
Well, I don't want to end it. All right, well,
Well,
you just
you
have
can-
to show them, you just have to hold it like this.
No, Dad, you can end
can
the
see.
video and connect them together.
Okay, so I guess you connect these. Okay, so here you go is the what we have for materials. So first of all, what you guys are going to be doing is if you look at the assignment for today, I'm going to read the purpose. So come a little closer, Parker. I'm going to read the purpose to you guys, and then we'll get going on this. So if you look at the assignment, so step 1 is complete the following. Writing introductions that include predictive hypothesis and testable questions. So a good scientific introduction includes background information, the purpose of conducting the lab, a testable question, a hypothesis with independent and dependent variables clearly identified, incomplete sentences using the prompts in your assignment. So the purpose of the lab is provided, so there you go, okay? So watch your finger, it's about to cover up the camera in the back. All right, so this is what you guys have. So the purpose of the lab. The purpose of the energy of rolling balls lab is to investigate the relationship between mass of various sports balls and the amount of potential and kinetic energy it has while rolling down the ramp. So remember, potential energy is mass times gravity times height. Kinetic energy is 1/2 times mass times 1/2 times mass times volume squared, or excuse me, velocity squared. So we're going to figure that stuff out today. So if you guys look at, additionally, we will investigate how the mass of various sports balls is related to work being done to the ball and the power output used while the ball transverses the ramp. So remember, work equals force times distance, or you have to get the weight, which is a force, which is weight equals mass times gravity, and then times distance. And then power is, power equals work divided by time, okay? So a certain amount of work in time. So here we go. First of all, let's look at the materials, okay? So first off, I already told you the purpose of the lab, and that the different variables are the different kinds of balls that are used. Here we're using a basketball. Come around, Parker, so you can see all these. A basketball, you have a basketball, you have a
Lacrosse ball.
lacrosse ball, a golf ball. Those are the 3 different balls. Those are the things that I am changing with the experiment. Okay. Then the other variable would be the speed at which, or velocity at which the ball gets going, and also calculating the power and the work. Okay. So what else do you need? Well, we need a scale to measure the mass of the materials, and then you need a piece of paper, and you need the calculator, you need a pencil, and you need a meter stick, and then I'm going to use the phone as a timer. So also what I did was I made a ramp out of, I didn't make it, I found it in my backyard because I was working on another project. So this is a ramp, which is, and if you get a close-up, Parker, get a close-up over here. Okay, so you can see that this is 18 centimeters. Okay, and then the ramp itself is, let me look at this, we got 100 right there, and then 122 centimeters. Okay, so 122 centimeters, or 1.22 meters, is the is the length of the ramp, or the distance that we're going to be doing. So what we're first going to do is we're going to get the mass of each of these balls. So if you come over here, Parker, you'll be able to see that I'm going to first get the mass. We already talked about the height of the ramp, and we talked about the distance of the ramp. So the height was 18 centimeters, or 0.18 meters. The distance of the ramp was 1.22 meters, or 122 centimeters. And then, so we have the mass, we get the mass of the ball. So I'm going to turn this on. Can you see the number in there? You can see the numbers right there? Mm-hmm. In the scale?
Yep.
Okay.
Mm-hmm.
Are you sure?
Yes.
Okay. So, I'm going to put the basketball on the scale. Okay, Parker, what does it read?
573.
Okay,
Well, switching between 73 and 74.
Alright, so there's the, we'll use 574, okay? Now we'll get the lacrosse ball.
Same thing. About one.
So
No,
let's write that
143.
down. So we'll do a mass of basketball is, what was it, 574?
Yep.
Okay? And lacrosse, how do you spell lacrosse? Is that how you spell lacrosse?
I think there's an E at the end.
Alright, lacrosse, it's French. Alright, so we had 143, and then golf ball.
46.
We'll do 46, okay? So 46 grams, golf ball. Now, remember, before you guys do any calculations, you have to convert the grams into kilograms. So you move the decimal point 3 spots to the left, okay? So if you look at here's the mass of the 3 objects, okay? So now, the next thing that we're going to do is we're going to do the time trial of how long it takes each ball to go from the start of the ramp to the end of the ramp. So, first thing I'm going to do is I'm going to take, and I'm going to find, okay, it's my wife's phone, so now I got to figure out how to get to the timer.
Search up clock.
Clock on Google.
Yeah. And then the thing, you just pat the app. Wait, go back. Go back. So click.
Okay. All right. So stopwatch. Okay. So we got the stopwatch, right? Okay. So I'm going to start and stop at the point at which. Okay. So here we go. So at the top of the ramp, I'm going to do this 3 times. Okay. So ready, set, go. And then to the end. So the first one was 1.78. So I'm going to write that down for time 1, 2, 3 for basketball, lacrosse, and golf ball. Okay, so 1.78. All right, so reset. Okay. Start it here, ready, set, go. 1.64. And then we'll do it one more time. Alright. Reset, okay, ready, set, go. 1.74. Alright. So now, I'm not going to do it on here 3 times so you guys can sit and watch that. So we'll pause the video now and then we'll come back and I'll show you what those were. I'll post a picture of it, of the data times, so you guys can get all the information. But you have the procedure. So now you have what you guys are supposed to do today is the introduction based on the independent and dependent variable. You guys have the question is within the purpose of what we're trying to find with the different balls and then what we're measuring. And then additionally, you guys have the hypothesis with if I change the ball or if I switch balls, then blah, 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 okay? So I'm not gonna do it for you, you guys. Look at the purpose, look at the introduction stuff, and that will be in there. I will post the information of the data right here, so you guys have all the data results, and that's what I have for you today. You can pause it. All right, so I got all three of the data together. So what I did was I continued with the lacrosse ball, and then I did 3 times with the golf ball. Now, what you're supposed to have already done here is your hypothesis regarding the potential and kinetic energy of each of those. So that which one of these you think would have the most kinetic energy, 1 at the top, and 2, which one of these would have the most kinetic energy at the top and then at the bottom, okay, of the ramp. So that's what your hypothesis is based on. Here is the information as far as the results. So you have mass, which is 574 grams for the basketball. Lacrosse ball is 143 grams, and then 46 grams for the golf ball. Now the times are that, so remember you got to add those 3 times together for each and then divide by 3 so you can get the average time for each of those, and that's for your data itself, okay? So once you get that information, then what you do is start working on the other aspects of the you calculate the potential energy, you calculate the kinetic energy, and then you calculate the work, and then you calculate the power, and put all those things together in a lab report and follow the steps of each of the day. So if you have any questions, ask a teacher. If not, good luck, and last assessment, so let's finish it strong. Thanks.